we're presenting the ZIO integration layer into Magnum, which is a database client for Scala. So I'm August. My co-presenter is Jules, and we'll switch off presenting about halfway through. So the first thing to do when you're evaluating, a database client is to think like, what type of SQL queries are you writing? What is the landscape of database clients? And I can provide you some details on what makes Magnum unique among the field that we're pretty blessed to have as Scala developers. So the first question is that there's kind of four main categories of SQL queries. There's the CRUD operations, simple statements with a few joins. Sometimes you have to write complex SQL statements for reporting, or have to use JSON operators or CTEs in your queries. And then finally, you might have to write some dynamic queries, to build like a search page or to have some sort of dynamic use case. And all of these categories kind of ascend in terms of being common to being rare and being easy to being challenging. So like the CRUD operations, developers tend to write a lot of them, and they're very easy to implement, right? And they should be generated at compile time. Meanwhile, dynamic queries are much rarer, but they're much harder to get right, and we end up spending a lot of time on those. And a lot of database clients seem to tailor towards one of these categories of queries and maybe neglect the other cases. So when we look at the landscape of database clients, we kind of have three broad categories as well, right? There's object-oriented repositories, functional DSLs like Juke, Slick, and Quill, and just like plain SQL string interpolators like Doobie or Anorm. And all of these categories, have pros and cons that really depend on how you're going to be writing, what type of queries you're going to be writing. So kind of like object-oriented repositories, great if you're writing Java, derives all your CRUD operations with reflection. They have typically, some sort of difficult query language that's like pseudo SQL for simple statements. SQL interpolator, for complex SQL with native queries, and the Java E has some sort of painful and slow pattern to express dynamic queries. Functional DSLs, are great at the CRUD operations, and for simple statements with a few joins, it's very good. But it becomes very difficult with complicated SQL expressions. And the dynamic queries are good as well. And one final point on the functional DSLs is that they seem to make maintenance difficult. Both from a library and a user perspective. Compile times are slow. You need to understand two languages, and you have to always be on guard about inefficient queries being generated. And then finally, for string interpolators, you have to write all the CRUD queries yourself. Simple statements and complex SQL can be expressed very cleanly in the native SQL language. And then dynamic queries are very difficult to write, as SQL notoriously does not compose. And what makes Magnum unique is that it combines aspects of all three of these clients. So it currently supports any database with a JDBC client, basically, and it's focused on high productivity and low ceremony. It's a very small library in terms of lines of code, but it has a lot of interesting features that kind of compose well. And it is a direct style library, but Jules has been iterating on a very simple ZIO module that works really well and is very expressive. I've tried to play around with using like redesigning the library to use like free monads and finally tagless style, and the simplicity of Jules' design is really cool. And yeah, so here's kind of a walkthrough of kind of the basics of Magnum. We'll start off by defining a fragment, which is just some bit of SQL that you have in a string. You can interpolate values, very similar to Doobie or any JDBC library you've probably used before. You can compose fragments together. and it'll work fine, in any sort of query. You can you can call different methods on fragments to get different query types. So the .query method, will return you a query object that represents a SQL query. Similarly, you can do the same thing for updates, and same thing for like insert returning statements. And here's where things get interesting. So first thing, we're importing the Mag ZIO module, which is the ZIO module for Magnum. We're creating a transactor which wraps a Java SQL data source. It could be from any database, whether it's directly from the database, like the Postgres driver, or you could be passing Hikari CP connection pool. And then here we're running a few SQL queries in a transaction with this transactor.transact method, which we provide a function, and it returns a task of the users. And now the interesting thing is that this transact method accepts a Scala 3 context function with this like question mark arrow here. And if you're less familiar with Scala 3, a context function is basically like a function from an implicit parameter to a result. So this dbtx, we don't have to specify manually. It's added to the scope of this this method. It's in a sense a capability. And this run method here on update and on query requires an implicit dbtx or transaction. If you try to move these lines here at the bottom outside of the transact body, it will fail to compile. Okay, so your transactor itself is customizable. You can log query, like slow queries. You can define your own SQL logger. You can set the connection transaction to be, serializable or repeatable read. Batch updates are supported in an efficient way. And here's the first kind of like really interesting feature of Magnum is the repositories, inspired from the object-oriented repository style of libraries. So here we're defining our data model, which is a user with a few different common fields. It derives a DB codec, which is the type class used for reading and writing into JDBC. And it defines a few annotations, which provide information about the table. So it's a Postgres table, and we're mapping it from camel case to snake case. And we also provide an ID. And here we create, on this next line, we create an immutable repository of entity type user with an ID of long. And it generates all the common, read-only CRUD queries like count, like find by ID, and they can all be run within a transactional scope. You can also, interestingly, extend this immutable repository interface. So you can extend it, have an object that extends your immutable repo, and then you can aggregate, and put all of your related queries within that, that module, and have a good, regular organization of your SQL. Similarly, there's the repo, which extends immutable repo, and it derives the rest of these, CRUD queries for you. So here's a example. Notice that there's 3 type parameters to repo, and we'll get there in just a minute. Yeah, so not too much different. You can extend classes with repo. And here's where the third type parameter gets interesting. And that's where you have auto-generated columns in your database. So in this case, we have 2 auto-generated columns, which are the ID and the created date. And to model that, we can create a an entity creator class. In that case, it's this user creator here that has a first name and a last name. And then we define the user model like before. and we pass the entity creator as the first parameter, the entity is the second, and the ID is the third. And that lets us, use methods like insert returning, which takes, the user creator and returns the user. And this is like validated at compile time that the entity creator is like an effective subset of the user. So if there's a typo in the column names, you'll get that error at compile time without actually having to extend one of the classes. Okay, so another interesting feature is the dynamic queries. So Magnum has a spec interface, which lets you really easily build, like dynamic queries, and it makes it really fast to like write a, any sort of search page or dynamic filtering. It supports like, it has a few different methods that support pretty much all sort of SQL expressions you could want dynamically. And it supports seek pagination as well, which is much better than offset pagination, although it does support offset pagination as well. And you execute them by calling a method on a repository called findAll, and it will return you, your list of entities. Yeah, so it supports Scala 3 enums. There's different type classes for, different that you can import, giving you different behavior for some, whether it's like a Postgres enum or you want to serialize it to a string. And you can take a look at the Postgres module. And here's another interesting thing is the future-proof queries. So one of the issues, at least I've found when writing a lot of like raw SQL in Doobie or other in SQL interpolators, is that you end up having like a lot of stringly typed sort of code. And let's say if you like refactor a column name or you add a new column to a table, it's kind of hard to statically know where you need to update. Normally you have to do a find and replace in your code. And so with this table info class that Magnum offers, it uses structural typing to kind of derive that information at compile time. So here in this example, you can call create a table info class for our user creator and user. And then in your query, you can call you can alias it to u and call like u.all to get, the list of columns, and, just interpolate the table info itself to result in the table name. And it really reduces the, the burden of having to maintain some of these SQL queries. Here's just some more examples. You can refer to the column name itself or the Scala case class name itself, and if that changes, it'll be a compile error. And you can also pass like the entity creator classes themselves directly into your SQL queries. So, like in summary, I think Magnum kind of hits a sweet spot in terms of like these 4 common, query use cases. For CRUD operations, like the queries are derived at compile time. For simple SQL statements and complex expressions, you have the SQL interpolators. And for dynamic queries, you have built-in support for specifications. And now with Magnum, now with the ZIO module, which should be released this week, hopefully, you're able to integrate it with, a very popular effect system. Yeah, so I'm really happy with how the library is turning out, and would love to get your feedback on any features, and feel free to join our GitHub and make any issues or questions as you see fit. With that, I'll pass the baton over to Jules. Thank you very much.
Thank you, August. So yeah, next slide, please. Let's study Magnum plus ZIO, and let's see why. So please, next slide. And why? So next slide again, sorry. And so yeah, but first is just because I needed to access a database and I use ZIO. So I was like, okay, I could choose Magnum. And so why Magnum and why do I like Magnum? Next slide, please. So first, as August has just demonstrated, Magnum is very powerful. It brings lots of power. And for example, for us, the repo mechanism automatically providing you all the basic CRUD operation is amazing for your team productivity. For us, for example, it simplifies how we write our tests because we can just use this CRUD operation to write our test with confidence. Next slide. Thank you. So second reason is that Magnum is simple. So August said that this library is only 300 or 400 lines of code, which means that if you have an issue or bug with it, you can easily contribute to fix it. That's one of the biggest force of Magnum, I think. I love Doobie, I love Quill, but go read their code base and try to contribute. Good luck. Let's not even talk about Slick. So yeah, Magnum is a tiny library, relatively simple library, and that's one of these big force. Next. Third reason why I like Magnum is it's impure first or direct style first. And that's a great choice, in my opinion, made by August. So DB operation anyway are nothing else but side effects. So it makes sense for a library providing tools for this domain to be impure. Also, it allows any Scala style practitioner to easily adopt it. If you use pure Scala without any library, you can use that Magnum directly. But if you use ZIO or any FX system, um, these FX system provide you tools to lift impure code into the pure world. That's the basic thing that any FX system on the JVM needs to provide anyway. So the fact that Magnum is impure is actually great news for ZIO users because it makes the integration of Magnum in ZIO super simple. Next. And last reason for me to really like Magnum is that, as we will see, Magnum with ZIO is exactly the same as Magnum without ZIO. And so, yeah, enough talking now. Let's go into the code and let's see how it works, how we go. So here is how it works. The first step to integrate Magnum in a ZIO project is to add the Magnum ZIO dependency in your project, and then to add the Magnum ZIO module import in your code. And the second step is simple. Next, please. Done. There is no second step. Oh, please, previous one. Yeah, there is no second step. That's it. You're done. You have integrated Magnum with ZIO by just adding your dependency, the dependency, and the import. Yes, that's simple, and that's the beauty of it. So now let's see how you would code with Magnum and ZIO, and what's the diff with coding with or without ZIO with Magnum. Let's first study the first helper that Magnum provides you. It's named Connect. Next slide, please. So here is the diff between raw Magnum and Magnum with ZIO. So in this slide, we see the connect without ZIO. So you can see you have a connect function, you pass a data source, and then you pass a query, and it returns you a vector of A or any value, and the value here is a vector of A. And below, you can see how you would do the same thing, but with ZIO. So you have a connect function, you pass a data source, you pass a query, and you get a task of value instead of just a value. So as you can see, there is no difference. The only diff is that connect, instead of returning a value, returns a task of value. That's it. Nothing would change on how you write your Magnum code. Only the return type of this helper change. That's beautiful. So now let's study how the transact helper works. So first, let's quickly see how the transact helper would work without ZIO. So what's happening here? First, we insert a new car. Then we updated catalog with this new car. If a catalog update didn't update anything, we fail and we roll back the transaction by throwing. Otherwise, we return the new car. So now let's rewrite the same code, but with ZIO. And can you spot what I've changed? yes, you cannot spot what changed because nothing has changed except the return type, of course. And that's the beauty of Magnum. Magnum is simple to use, and Magnum plus ZIO is as simple to use because it's the same code. You will write the same code. And that's amazing. And Magnum is so simple that that's it. That's all I have. That's all you have to know about how to use Magnum with ZIO. There is nothing more for you to know, and so there is nothing more for me to show you. I repeat it. Magnum is simple library. That's the beauty of this library, and Magnum plus ZIO is as simple as using Magnum without ZIO. So before to move to the next section of this presentation, I want to give you a quick tip to make your Magnum code performant. Next slide, please. So the quick tip is when you throw an exception, be sure to use control throwable. This will avoid for your exception to build the stack trace, and this will also avoid your APM to collect this as an error. That's just simple. You can have a look at the Scala documentation. Let's move on. So what's next now for Magnum plus ZIO? Well, first, we look forward to receive your feedback about using the ZIO integration. So as August said, we merged it today. We will release the new version probably today or tomorrow. And yeah, we are using it in production for 3 months because what is in the library is copied from our code at work. And so the second thing, what's next, is the ZIO integration was super easy to implement thanks to the simplicity and the choices of Magnum. So there's no reason we could not provide more integrations. So if you want to help and contribute for your favorite FX system or your favorite stack, please do. Have a look at how we did it for ZIO, and I'm sure you will be able to do it for your own stack in a minute. So time for a quick conclusion. Yeah. Next. So Magnum is a beautiful, simple, yet super powerful library. August made the choice to make it impure, and that's an amazing choice for the entire Scala community. It allows you to integrate it super easily in your favorite stack without adding complexity in the usage of Magnum. Magnum is simple to use, and Magnum wrapped in your favorite stack is the same. It's as simple to use and as powerful. So thank you. Last slide, please. Thank you, everyone.